Hello, this is Ms. DB. In this video, we are going to look at special products of binomials. So first off, we're going to review multiplying binomials with FOIL. And then we're going to look at some special cases where you can use a formula as a shortcut to multiplying two binomials together. So first, let's review FOIL, the FOIL method. So FOIL stands for first times first. So in this example, x plus 3 times x plus 2, we would multiply the x times the x, which is x squared. And the reason it's x squared is because we could put the exponent of 1 on each of these and then use the rule that says when you multiply like bases, you add the exponents. So x times x is always x squared. Then we're going to multiply the outermost term, which is farthest away from the outermost term. So x times 2. And usually we would write that as 2x. Then we'll multiply the innermost times the innermost. So those are the two that are closest together. So 3 times x. And then finally the last term of the first binomial times the last term of the second binomial. 3 times 2 is 6. Then we're just going to write these in horizontal order. So x squared plus 2x plus 3x plus 6. And then usually when we FOIL, we check to see if there's any like terms. There often will be. 3x or 2x plus 3x, we add the coefficients. 2 plus 3 is 5x. So this here would be our final answer when we multiply these two binomials together. Now this isn't the only way to multiply two binomials. You can use the table method, or you can stack them vertically, or you can use the distributive property twice. But this is a good way to keep track, and you'll see this often in your future math classes. So on these problems, you're just going to practice multiplying these binomials together. You can practice with FOIL, or you can use one of the methods you learned about in a previous assignment if you prefer. Let's do number 4 together. In number 4, it says that we have x squared plus 5 times x squared plus 2. So I just made myself a little more room there. We're going to do this with FOIL. So it says to start by multiplying the first term times the first term. So that would be x squared times x squared. And we'll simplify after we do all of our first multiplications. So that's the f. Then we do O, the outer. So the outermost is x squared times 2, way over there. And there's a plus sign because there's a plus sign in front of the 2. So x squared times 2. Then we do the innermost times the innermost. So the 5 times the x squared, and again there's a plus because there's a plus sign in front of the 5. And then finally we'll do the last term times the last term. So the last term of the first binomial times the last term of the last binomial. And we look at the signs and they're both plus, so this will be a plus. 5 times 2. Now I'm just going to simplify each of these products. So x squared times x squared. When you have the same base, x, and you're multiplying, the rule is to add the exponents together. So 2 plus 2 is 4. Then we have x squared times 2, which we write the coefficient in front, and then the x squared. And then here we have 5 times x squared. You don't need the dot for multiplication. And then 5 times 2 is 10. And then we check if we can add any like terms. And as often is the case, there will be the two middle terms are often like terms, not always, but in this case they are. 2x squared plus 5x squared, you only add the coefficients in front and then write the x squared down. So this then is our final answer, x squared plus 7x plus 10. Make sure you show your work on these while you're completing this part of the assignment. Now let's look at what happens when we get to a problem like number 6. Number 6 says x plus 3 times x plus 3. So I'm going to try this with FOIL and see what happens. Something interesting will happen. So we start with f times first for the FOIL. F times f is x times x. And then we have the outer times the outer, x times 3. And then the inner times the inner, 3 times x. And then the last times the last would be 3 times 3. Well, x times x is x squared. X times 3 we would write as 3x. 3x we leave as 3x, and then 3 times 3 is 9. So when we add our middle term to our middle two terms together for the like terms, we would get x squared plus, well, we have two of these, so instead of writing 3x plus 3x, I could write 2 times 3x if I wanted to. It's the same thing. And the reason I'm doing that is because that's the way the formula is set up. And 2 times 3x is 6x, of course, which I could have got by 3x plus 3x. Either way, it's the same thing. But this is called a perfect square trinomial. If you are multiplying the same thing times the same thing, the exact same binomial times itself, I could have written this as x plus 3 to the second power, because squaring something is the same as multiplying it by itself. So there's a special formula when you have binomials like this, and it says that you can take a plus b squared is equal to a squared plus 2 times the product of the first term times the last term plus the last term squared, which is why I wrote in this line so you could see that that's what we have. We have the first term squared, x squared, plus 2 times the product of the first term times the last term, so x times 3, or 3 times x, and I have to multiply that by 2, plus the last term squared, 3 squared, which was 9. So using the formula might be a shortcut to FOIL. You don't have to use the formula. You could just use FOIL. Let's make a screenshot of this formula using the minus, because you notice that if it's a minus b squared, this sign right here will be a minus sign. The other one stays a plus. This is still a plus, but this one is a minus sign. So it's important that you note that. So I'm just going to copy that formula so we can do a problem on the next page like this. Alright, let's do find one with a minus. Let's do number 13 like this. So here's the formula. Let me give myself a little more space again. Alright, so we are going to take 3x minus 7 to the power of 2, which is the same as 3x minus 7 times 3x minus 7. And I'll do it once with FOIL, and then I'll do it once with the formula. And then you can kind of judge which one do you like better. And you can do these problems with either FOIL or with the formula, but it's nice to use the formula sometimes to practice and see if you are able to do these problems quicker with it. So with FOIL, I have to rewrite this as 3x minus 7 times 3x minus 7. Both of them would be minus. And then I would multiply 3x times 3x. And then the outer times the outer would be 3x times negative 7. Or I could have made this be a minus sign. And then the inner term would be minus 7 times 3x. I'll put in parentheses. And then finally the last term times the last term. Negative 7 or minus 7 times negative 7. All right, let's simplify what we have here. 3x times 3x. That's 3 times 3 is 9. X times x is x squared. X times x is always x squared. I started writing a plus sign, but I'm going to change that because now I have 3x times negative 7. Multiply the 3 times negative 7, you get negative 21x. And then here I also get minus 21x. And then negative 7 times negative 7 would be a positive 49. Let's look at our middle two terms. They're both negative. They're both 21x, negative 21x. So negative 21x minus 21x, you would add the two and take the sign of both. So 9x squared minus 42x plus 49. And that's as simple as we can get. We're done with it at this point. All right, let's do the same problem using this formula here. All right, so we have a minus b. A means the first term squared. So the first term squared would be 3x. So a is equal to 3x, and b is equal to 7 using this formula. So we have the first term squared. Now we have to do minus 2 times a is 3x, times b is 7. And then we have to do plus b squared, plus b is 7 squared. Then we simplify, 3x squared. 3x squared means I have to take 3 to the second power and x to the second power. Then here we have a lot going on here. We have a lot of multiplications. I think I'm just going to multiply the first part, 2 times 3. That would be minus 6x, and then I still have to multiply that by 7. Plus 7 squared is the same as 49, because 7 times 7 is 49. Now I'm going to keep simplifying. 3 squared is 9, x squared. Now I'll finish my multiplying. 6 times 7 is 42, and I had an x there, plus 49. So these two match each other exactly. 9x squared minus 42x plus 49. So either method will give you the exact same answer, and you could do both methods to check that you completed it correctly. And as you get more practice with these, they'll get easier. Both methods will get easier for you to do some of the steps in your head. All right, let's look at 15 and 16. These are not the same as the last ones. This says x plus 4 times x minus 4. So if we FOIL these together, first times first would be x times x. Outer times outer would be x times negative 4. X times negative 4. And the inner times the inner would be 4 times x. And then my last term times my last term would be 4 times negative 4. So be careful with your negatives. Then we would simplify. X times x is x squared. X times negative 4 is the same as minus 4x. 4 times x is a plus 4x. And then we have 4 times negative 4 would be minus 16. So when we go to combine our like terms, we have negative 4x plus 4x. Negative 4x plus 4x. Well, if you have a negative 4 plus a 4, that's equal to 0. So these are a very special case where the middle term cancels each other out. And we're left with just the first term times the first term minus the last term times the last term. So we're left with FL, basically. FL. So x squared minus 16 is the final answer. We don't have to write anything for the middle term. We don't write 0x. We just skip it and write x squared minus 16. And these are known as the difference of squares. In order for this to work, it has to be exactly this way. X minus 8, x plus 8 is another example, x plus 4, x minus 4. It has to be the same first term in each binomial, the same last term in each binomial, but one has to be positive, one has to be negative. If they're both positive or both negative, it doesn't work. Then it's like these. So you can't use this rule unless it's set up exactly this way. Let's do one of these problems using this formula. And the formula is just a plus b times a minus b equals a squared minus b squared. It would be great if this worked all the time when we were multiplying binomials, but it does not. It only works occasionally. It has to be in these very special cases. Let's do number 20 using this formula. And the formula is easy to write. It's just that if you have a plus b times a minus b, the formula is a squared minus b squared. Note that it's a minus here, not a plus. If you write a plus, it'd be wrong. It also works if you have a minus b times a plus b. You get the same result, a squared minus b squared. But you always have a squared minus b squared for your final answer. So we'll do this again with FOIL, and then we'll do it with the formula. You'll get the same answer either way. Be better. If you don't, you made a mistake somewhere. So with FOIL, I'm going to take 3x times 3x plus the outer would be 3x times, there's a minus in front of that 9. The inner would be 9 times 3x, and then the last term times the last term would be 9 times negative 9. Now I'll simplify each of these terms. 3x times 3x, you multiply 3 times 3 and get 9. X times x is x squared. All right, then we have 3x times negative 9. 3 times negative 9 is a negative 27. I'm going to erase the... I'm trying to erase this. There we go. That should be a minus 27x. And then 9 times 3 is 27x again. And 9 times negative 9 would be minus 81. Look what happened. We have minus 27x plus 27x. These will cancel and we'll end up with 9x squared minus 81 for our final result. If we use the formula, which formula do we have? We have this one. We have a plus b times a minus b. A is equal to 3x. B is equal to 9. So the formula says that we take a squared minus b squared. Maybe we should put these around the formula so we know that we have to square the whole thing. So 3x squared would be 3 squared times x squared, multiply or raise each power to the second power, each factor to the second power, minus 9 squared. I could have just done that, but 3 squared is 9, and 9 squared is 81. So again, same answer either way. The formula is a little faster, but if you're not sure you can use the formula correctly, then you're better off foiling because you won't make a mistake if you do it the same way every time. The next part of the worksheet is practice. This is practice from all of the assignments you've done this week. For example, in number 22, we are just using this distributive property to multiply a monomial, 4x, times a polynomial. In 24, we're foiling, practice foiling. In 25 and 26 and 27, you can use the special formulas that we learned today, 2 different ones. In 25, if you say the answer is x squared plus 64, you would be wrong. That's not the answer. That would be something you maybe would be able to do in 27, but not in 25. So make sure you look back and make sure that you're using the correct formula when you do these problems. Number 28 is a problem that we haven't practiced before, but you would do the distributive property twice for 28. Let's look at just how to start this one. This is kind of a bonus problem, so you can see if you can figure this out. So what you would do in 28 is you would first do the distributive property with the first term in the binomial. You'd multiply x times x squared, and then x times 5x, and then x times 8. And then you would go back and you would do the second term in the binomial times each of these. 4 times x squared, 4 times 5x, and 4 times 8. Let's write this out and then you can finish this one. So to start with, you would have x times x squared. I just did that first multiplication. And then I would do x times 5x. And then I would do x times 8. Now I'm going to go back and do the second term of the binomial times every term in the polynomial. So 4 times x squared. And then 4 times 5x. And then finally 4 times 8. So I have all of my multiplications written out. I have to simplify each of these, and then I have to combine my like terms. So we would have to, let's for example just start x times x squared. The rule is that when you have the same base, you add their exponents, so that's 1 plus 2 is 3. And then I would simplify this part. X times x is x squared, and there's a 5. And then you would keep going and simplify all of these multiplications. And then you would look for like terms. And there's probably no other term that has an x cubed, so that would be the first term. And then you would combine something plus something to get the x squared term, and then the x term, and then it'll probably end with just a coefficient of 32 probably will end this. So try that problem, see how you do. It's a lot of multiplying, but that's all right. and then ending with a couple more binomials, and number 30 is a special one if you want to look back and see what formula you could use to make that go a little faster. All right, make sure that you come and visit me during my homework help hours or during the ASC when a math teacher is there, and we'll help you out with this worksheet. Have a wonderful day. Thank you.